Now take down this first question. Kilogram cylinder is suspended from a ceiling by cable wires attached to different points. So you have your cable wires attached to point C, to point C, to point B, and to point D. Determine the tension. Determine the tension at AB. Determine the tension at AB, AC, and AD. So they're asking us to determine the what? The tension at what? AB, tension at what? AC, and the tension at what? AD. Determine the tension at AB, AC, and AD. For you to solve this particular question given to you, the major thing here is to calculate for our tension for point AB, AC, and what? AD. Now the first thing you should do is get your coordinate first. Get your coordinate first. But in our question that they gave to us here, they've already given us our coordinates to be what? 3, 0, 3, 2, 0, 2, 4, 0, 2. So these ones, they are our coordinates for each point. So at point B, we have 4, 0, 2. At point C, we have -2, 0, and what? -2. At point D, we have what? -3, 0, and 3. Then at point A, we have what? 0, 4, and 0. Now the first thing that should come to your mind is take this coordinate into what? Vector coordinate. You are giving your coordinate as figures here. What do? Convert these coordinates that are given to you as figures to vector coordinate. You understand? So convert this with your A here to vector coordinate. Now if you want to do that, you simply write your coordinate given to you. Now the first thing you do is at point D, convert this coordinate to a vector coordinate by what? Adding your what? I, J, and K. So if you add these ones here, then you are simply converting this to a vector coordinate. So the first one we have is at point D, we simply have what? -3I. The next one is what? 0J. The last one is what? 3K. So you succeeded in converting your D point to a what? A vector coordinate. Now the next one is at point C. At point C, you have what? -2I, 0 what? J, and what? -2K. This is for point C. Now for point B, to convert to vector coordinate, you simply have what? 4I, 0J, and what? 2K. This is your vector coordinate for point B. Now for point A, which is the last one, you have your what? 0I. The next one is what? 4J, and the last one is what? 0K. Now this is what we'll be using in calculating for both our what? Position vector, magnitude, and what? Unit vector. Now the next step, I've given you first step. The first step is convert your values given to you to vector coordinates. That's the first thing. Now the second step is look at your diagram you have here, which is this. Draw a free body diagram. Draw a free body diagram. It simply means replicate this diagram, but not exactly what you are seeing here. That's the meaning. So if you want to do that, your free body diagram, which is your step 2, free body diagram. Now, in drawing your free body diagram, what do you see? You are seeing what? 10 kilogram here. So your free body diagram will simply be of this nature. This and what? This. They are not telling you to draw exactly what you are seeing here, but just draw something that looks like what you have on your exam paper. So you have 1000 kg here, which is this. You have this tension here. You have the second tension here, and you have the last tension here. Now this is your point D, this is your point C, and this is your point what? B. Now, down here, what are you seeing? You are seeing what? 1000 kilogram. But they told you that this cylinder was hung on a what? A ceiling. So since we are seeing 1000 kilogram here, what should come to your mind? Acceleration due to gravity, since it was hung on a ceiling. So if you want to do this, here, we'll simply have what? F is equal to what? mg. This is how you calculate the force at this point. To calculate the force at this point, what do? Mass, which is this, times acceleration due to gravity. So you simply have the what? This point here, which is 1000 kilogram, to be 1000 times 9.81. If you punch this on your calculator, you simply get what? The force for this particular place, which is at point A. So if you punch this for the force at this point here, you simply have your force here to be what? 9810 Newton. So you've succeeded in getting the force at this point. Now they're asking you to get the force or the tension at point A to B, A to C, and to A, from A to what? D. That's what you are asked to get. Now, since you've gotten this to be what? 910 Newton, you've already succeeded in getting the tension or the force for this particular place. Now, how do we get the force for these other ones which we are asked for? AB, AC, and AD. We've gotten our step 1, which is this. Our step 2 is what? Draw the free body diagram. Now, the third step, which is step 3, is what? Write the vector form of your tension given. Write the vector form of your tension given. And what are the tensions you are asked to look for? The tension for AB, the tension for AC, and the tension for what? AD. So the next step is write the vector form for each of these tension given. Vector form for each of these tension given is number 3, the vector form. So for the vector form for AB, let's say the vector form for what? AB. The vector form for this will simply be what? TAB. That's the tension for what? AB multiplied by your unit vector. So we can use unit vector AB. That's the vector form for the first one. Now the next one is the vector form for what? Tension what? AC. AC is equal to TAC multiplied by your unit vector AC. The last one is AD. So what is the vector form for this AD? The vector form for TAD is equal to tension AD multiplied by unit vector AD. So this is the vector form for each of your tension given. So you can use this to start calculating for your tension given. But first, what are we seeing here? We are seeing what? Unit vector. So what do? You simply break down this unit vector. Remember or recall, I told you our unit vector, to calculate for your unit vector is simply what? U caret is equal to your vector, which is your position vector, divided by your magnitude of the position vector. So you simply use this equation to calculate for each of your tension given. So we are calculating for what? Your unit vector for AB, you are calculating for the unit vector for what? AC, and you are calculating for the unit vector for AD. Let's calculate the unit vector for AB. So here you simply write what? Unit vector for what? For AB. And you know that when you talk about vector AB, you are simply referring to AB divided by magnitude of what? AB. So first, what is your AB? You know the position vector AB. Bring out your position vector. This is A and this is B. So you simply multiply, you are seeing this here, AB here. You are seeing AB here. So what do? You bring down your AB. AB position vector is equal to, what do? Simply means B minus A. That's how to calculate for position vector. So if you do B minus A, what is your B position? What is your B coordinate? Vector coordinate. Your B vector coordinate is simply what? 4I plus what? 0j plus what? 2k minus this sign here. What is your A vector coordinate? Your A vector coordinate is what? 0I plus 4j plus what? 0k. Now if you do that, you simply arrive at 4 minus 0 is what? 4I. 0 minus 4. Simply have minus 4j. Then the next one is 2 minus 0. Simply have what? Minus what? 2. 2 minus 0. You simply have plus 2 what? K. So this is your position vector. Your position vector for what? AB. So you succeeded in getting your position vector. Now the next thing is, how do you calculate for the magnitude of AB? We already have this as your position vector. So let's get the magnitude for this. Now recall, for us to get magnitude for this position vector, what did I say? I told you that to get magnitude is simply what? X squared plus what? Y squared plus Z squared. Now if you apply same approach to what you have here, you simply have your AB, your position vector AB to simply be what? The square root of what? What is your x? Your x is what? 4I all square plus minus 4 all square j plus what? 2 all square, which is your j. So if you do that, you simply have what? 4 raised to the power of 2 to simply give you what? 16. What are you seeing here? 4 raised minus 4 raised to the power of 2 is simply minus 4 times minus 4. Minus is going out. What are you having? 4 times 4. 4 times 4 is what? 16. Plus 2 all square. 2 all square will simply give you what? 4. Now, what do you simply do? You punch your calculator. 16 plus 16, 32. 32 plus 4, 36. So you have the square root of what? 36. The square root of 36, you simply arrive at what? 6. So you succeeded in getting the magnitude and you've gotten your position vector to be x. What is the next thing to get your what? Your unit vector. We know that unit vector AB is simply what? Position vector, which is what? 4I minus what? 4j. Then the last one is what? Plus 2k divided by 6. So what will you have? In essence, you simply simplify this to be what? 4I divided by 6 minus 4j divided by what? 6 plus what? 2k divided by 6. So if you punch this with your calculator, this will simply give you 2 here, 2, 2 here, 3. This simply give you 4 divided by 6. We have what? 0.667. And let's leave it in 3 decimals. Minus 4 divided by 6 too is what? 0.667j plus 2 divided by 6 to give it 0.333k. So we succeeded in getting our unit vector for what? We succeeded in getting our unit vector for the first one, which is what? A. So we can write the first one, which is for tension AB. Tension AB is equal to this. Tension AB is this. So we have TAB multiplied by what's our unit vector? Our unit vector is 0.667I plus minus 0.667J plus 0.33 what? 38. So these are the first one. We've gotten this. Let's mark this so we won't forget what we have here. So the next one is the vector for what? AC. Now leave this. Get your unit vector for AC. How do you get your unit vector? Now for the second one, for AC, unit vector AC. To get your unit vector, I told you your unit vector AC is simply what? Your position vector what? AC divided by the magnitude of the position vector. AC. That's what we discussed earlier as. So this is the formula you use to get your AC, your position vector, and your unit vector. But what should come to your mind is get your position vector first before your what? Your unit vector. So you want to get your position vector for what? For the position vector TAC. You simply have your position vector to be what? C minus A. That's what we used to do. That's what we did here. So the same concept here, apply it to what you have here. So you simply arrive at what is your C. You get the vector. You get the vector coordinate for C. You subtract it with the vector coordinate for A. Now what is the vector coordinate for C? The vector coordinate for C is simply what? Minus 2I plus 0j minus what? 2k minus what's the vector coordinate for A? We know vector coordinate for A to be what? 0I plus 4j plus what? 0k. Now this is the vector coordinate for this. So what you do is take this, subtract it with this. You will have your position vector to be what? The position vector of what? AC. Now to get the tension position vector for AC, you simply have what? Minus 2 minus 0. You simply have minus what? 2I. The next one is plus 0 minus 4. You simply have what? Minus 4j. Then the last one is what? Minus 2 minus 0. Simply what? Minus 2 minus 0. So you have this as what? Minus what? 2. And minus 2k. So this is your position vector for what? AC. Let's calculate for our unit vector. But we know that for you to calculate for unit vector AC, your unit vector AC is simply your position vector divided the magnitude of your position vector. Now for you to get your magnitude, you simply what? Bring down your position vector, which is what? Minus 2I minus 4j minus what? 2k divided by the magnitude. Now we have a formula we use to calculate for magnitude. Now the magnitude of what? Minus 2I minus 4j minus 2k. Now if you apply the same approach, which is this, in calculating for the magnitude of this vector. So let's calculate for the magnitude first before we calculate for our unit vector finally. So to get the magnitude, which is TAC, magnitude is equal to, well, in our position vector, so we have minus 2 all square plus bracket minus 4 all square minus what? Plus what? Minus 2 all square. So if you do this, you simply arrive at what? Square root of what? 4 plus what? 16 plus what? 4. So 4 plus 4. 4 is, this is giving you 20. 20 plus 4, you're having 24. So you have to get the square root of what? 24. Square root of 24. You simply arrive at what? 4.899. I told you 3 dp. 3 dp. So this is the magnitude for your tension AC. So take down this magnitude to this equation we have here. So your unit vector for AC will simply give us what? Minus 2I minus 4j minus 2k, all divided by what? 4.899. What do you do? I told you simplify this further. If you simplify this, you have what? Minus 2I divided by what? 4.899 minus 4j divided by 4.899. Then the last one is what? Minus 2k divided by 4.899. So you simply punch your calculator. So if you do the first one, you arrive at what? 0.4082. This is your minus here. The next one is minus. If you point this in your calculator, you simply arrive at 0.816. 816 what? 4. G. This is your I. Then the next one is this. You will have the same answer with this. 0.4082k. This is 4 dB. So this is what? This is 3 dB. This is 4 dB. So let's take this to what? 3 dB. Taking this to 3 dB, we simply have what? Minus 0.408 I minus 0.816J minus 0.4008K. So this is what the next one for what? TAC. Now, let's leave our answer to be in this manner. So for TAC, position vector TAC, our vector form will now be what? TAC brackets, that's multiplied by what we have here, minus 0.408I minus 0.816J minus what? 0.408K. So this is your final answer. So what we'll do is we are marking this. So we've gotten this, we've gotten this. What's the last one to get for what? ATAD. The next one we have to get is for what? Tension AD. Tension AD. So we have tension AD here to be what? TAD multiplied by the unit vector for what? AD. So if we do that, we simply arrive at, to get the unit vector, let's get the unit vector for AD first. So getting the unit vector for AD, we know that AD is equal to position vector AD divided by magnitude vector TAD. So first we get our position vector, the next thing we will do is to get the magnitude. So let's get the position vector, which is what? TAD. Now to get your position vector, TAD is simply what? D minus what? A. And we know our D vector coordinate to be minus 3I plus 0J plus what? 3A minus. We know our A coordinate, vector coordinate to be what? 0I plus what? 4J plus 0K. Now if you do this, we simply arrive at minus 3 minus 0. This is what? Minus 3I. 0, which you have here, plus 0. 0 minus what? 4. 0 minus 4. Or we arrive at what? Minus 4J. Then the next one is 3 minus 0. 3 minus 0, we simply have what? Plus what? 3K. So this is the position vector, this. So what you do is take this to this equation here, then get your what? The magnitude for this vector. So if you do that, we simply arrive at this, which is what? Minus 3I minus 4J plus what? 3K divided by the magnitude of what? Minus 3I minus what? 4J plus what? 3K. So we are getting the magnitude for this. And I told you to get the magnitude for this. The magnitude for what? The magnitude for TAD is simply what? The square root of x squared plus y squared plus what? Z squared. If you get the magnitude for this, we simply have what? This to be minus 3 all square plus minus 4 all square plus what? 3 all square. So if you solve this, simplify this further, you simply have what? 9 plus 16 plus 9. 9 plus 9, 18. 18 plus 16. Simply arrive at what? 34. Now the next thing is, what is the square root of 34? The square root of 34 is simply what? 5.830. You approximate, because we are seeing 9 after the 0. So you approximate it to 1. Now this is 3dp. Take this to what you have here. You simply have what? Minus 3I minus what? 4J plus 3K divided by 5.831. This is what you have. So if you do this, you can still simplify what we have here to be what? Minus 3I divided by what? 5.831 minus 4J divided by what? 5.831 and plus 3K divided by 5.831. Now if you do this, you simply arrive at what? Punch this in your calculator. This will give you what? Minus what? 0.514 3dp minus 4 divided by this. So you punch 4 divided by you have what? 0.686 plus this J. This is your I. This divided by this, you'll simply arrive at 5. This 3 divided by this, you simply arrive at 0.514. So this is your unit vector. So what you do is simply take this your unit vector into this equation here. You simply arrive at TAD. That's what we calculated for. Is equal to TAD. Your unit vector, what's your unit vector? Minus 0.514i minus what? 0.686g plus 0.514k. This is your equation. So we've simply gotten what? The 3 equations which we need. This is the first one, this is the second one, and this is the last one. So what you do is simply bring down these equations together. So if you bring down these equations, you simply arrive at solving the equations. Got it? The first one is, what's the first one? TAB, position vector, is equal to TAB 0.667i minus 0.667j plus what? 0.333k. And the second one is for what? TAC, position vector TAC. We have TAC here to be what? What is our TAC? 0.4 minus 0.408i. The next one is minus 0.816j, while the last one is what? Minus 0.408k. Now what's the last one? The last one is what? Position vector of what? TAD. And TAD will give us what? TAD. It's simply what? What's our TAD? This is what we got. So you have minus 0.514i minus what? 0.606j plus 0.514k. Don't be confused. What you do is simply get your calculation, calm down and do your what? Calculations. You have your what? Your specific answer. So you succeeded in getting our third step. So this is our third step. Now the next step is we've already succeeded in getting each of our tension for position, that's the position vector for each of the tension we are asked to look for. Now the first one was this, the second thing is this, while the third one is this. So the next thing is use what you have here to multiply all through. You expand this. So if you expand this, you arrive at what we have here. So this is our equation 4, 5, and 6. So the next thing we have to do is look at what you have. You have I component, I component. You have J component, J component, and J component. You also have K component, and K component here. Why then don't you group all the components to one side? And after grouping them, what do? You equate them to 0. That was what the law of static equilibrium says. So if you do them, if you group the component, let's take the first one, which is your I component. Let's group the I component. For your I component, you simply have 0.667. Since you are grouping them to I component, you have TAD here. The next one is minus 0.408 TAC. While the last one is minus 0.514 TAD. So this is your equation 7. Next one is go back to the next component, which is J component. So for the J component, we simply have what? The first one, which is what? 1 minus 0.667 TAB. The next one is minus 0.816 TAC. While the last one is minus 0.606J. There's no need for this J. TAD. This equation was 8. Now the next thing is to get your what? Your K component. Now for your K component, For your k component, the first thing you have is 0.333 k. Instead of using your k, you have a what? TAB. The next one is minus 0.408 TAC. While the last one is what? Plus what? 0.514 TAD. So this is your equation 9. So you succeeded in getting equation 7, equation 8, equation 9. From what we've already gotten, which is your I component, your J component, and your K component, what you do is you apply the law of static equilibrium. Now, what's the law of static equilibrium? I told you earlier that the law of static equilibrium, there are 3 types. The first one is sum of forces along the x was 0, sum of forces along the y is 0, and sum of forces along the z is what? 0. Now, we are seeing this component here. Remember, the coordinate for point A, it was what? 0, 4, and what? 0. And the force you have the force of what? 9810. Now, what do? Look at this place here. If you have this to be what? 0, 4, 1. This was your coordinate. Convert this to what? Vector coordinate. If you do that, you simply have what? You simply have your A to be what? 0i, 4j, and what? 0k. Now, what are you seeing here? You are seeing what? 9810. And this 9810, all the forces, all the tension forces was acting upon this force here, which is what? 9810. So if you are to equate this equation for I component, J component, and K component, you simply do what? For your I component, equating them to 0, you will simply have 0.667 TAB minus 0.408 TAC minus 0.514 TAD is equal to 0. For your J component is equal to minus 0.40. What's the J component? Minus 0.667 TAB minus 0.816 TAC minus what? 0.606 TAD, and you're equating it to what? 9810. So you did have force and the force was 0, that's it was not given to. Then you are equating it to 0. But here you are equating it to what? 9810, because your force was given as what? You had a particular figure for your force, which they gave you the mass to be what? 1000 kilogram. So we now use 1000 kilogram times 9.81. Acceleration due to gravity. You can use 9.81 or you can use 10 meter per second square, depending on what you are given in your exam paper. Now, the next one is your K component. For your K component, you simply have what? 0.333 TAB minus what? 0.408 TAC plus 0.514 TAD equated to what? Z. So now what do? You simply solve your equation simultaneously. But in a case where you are in your exam hall and they ask to solve this simultaneously, please quickly bring out your calculator and follow this step. So we are talking about how to solve simultaneous equation easily. So we have 3 simultaneous equations. So what you do on your calculator is press the mode button. It will take you to where you see complex, base, and matrix, vectors, tables, statistics, and whatever. And the number 5 there, we are seeing what? Equations. So that's what we want to solve, and we want to solve a simultaneous equation. So you click 5 here on your calculator. And after punching 5 on the calculator, this will display. So the first one, you are having a simultaneous equation. The second one too is a simultaneous equation, but what we are dealing with is four boxes. So the second one here is 1 2 3 4. So since we are having four boxes, so we have to use this one here, so the number 2. Now look at your number 3. Your number 3 is having ax raised to the power of 2. Now when we see something like that, we are talking about a quadratic equation, but that's not our interest. Our interest is the simultaneous equation. So you punch 2 on your calculator. Now it takes you to this windows where you will see where you are going to put all your figures. So let's input our values on this place where we are now. So after inputting your values, this is what you have here. So we have the first one, the first row, the second row, and the third row. So after that, you press your equal to sign. Now this is our first answer. This is our first answer, and we can see our answer to be what? Minus 5260.33. So you can choose to leave your answer in 2dp, or you can choose to leave your answer in 3dp. I told you 2dp is 2 decimal place, and the 3dp we are talking about is the 3 decimal place. So you can choose to leave your answer to be minus 5260.33 or 34, as the case may be. So the next one, you press equal to, you see the next answer, which is minus 1696.5. So what we have here, the first one here is our TAB, which is the first one. Now the second one, which is minus 6462.33, that's the TAC. This tension, TAC, tension for what? AC. Then the last one, which is what? Minus 1696.52. So you can approximate it to be 53. So this is your answer for what? For your TAD. So in cases where you are given a simultaneous equation and you don't have time, use this approach to tackle your simultaneous equation. After doing that with your calculator, you now arrive at this answer here. Your TAB to be what? 1 minus 5263.18 Newton. You've gotten your TAC to be this and your TAD to be this. So this is the approach in which you use in solving 3D problems or 3D what? Calculations.